why do you think that your approach is better than compared solutions? Because I already have seen the navigation panels in like shopping malls, for example, or at the
Yeah.
airports, right? They are able to somehow locate me and to know where I am. So how is it different, or what different solutions they are using
Yeah.
nowadays?
So when we think about positioning or indoor positioning, or even outdoor, we have GPS at the highest level. Then we have Bluetooth beacons. I'll come to that in detail how they work. And then we have Wi-Fi. Then we have ultra widebands, which are again all hardware related solution, which means if you put all that into a single term, whether it's Bluetooth beacons, Wi-Fi, RSSI, or ultra widebands, the main disadvantage of those is two things. First, they are infra heavy, which means, let's say you want to enable accurate positioning in your environment or a factory or a shopping mall, you need to install those beacons everywhere at a regular distance. It's like having mini satellites in the physical space, right? Uh,
So beacons meaning simply some kind of a
yeah.
sensors, right? Within
Yeah,
the space.
some
Yeah.
sort of sensor which can stick on walls, it can stick on roof, right? So but you need to install them, like multiple of them. You need to install them, you need to maintain them, you need to charge them, they need to like form a mesh. So whether it's Bluetooth, whether it's UWB, there is a physical, infra required in the environment to be present for them to work, right? So and on top of them, although you have invested that much, let's say upfront in on infra, the accuracy level that they offer ranges between, let's say, 1 meter to as high as 5 meters, right?
Why such low accuracy, I would
Yeah,
say?
it's just a cost function of like how this technologies works again. So the underneath formula is still same. So how GPS used to work, it used to connect your device with this satellites in the space. How, let's say, Bluetooth works, it tries to triangulate your device position with respect to multiple sensors. So if you are in a room, and it will try to catch three sensors, like, hey, one sensor is in this room, one is in another hallway, another is in that hallway. It will try to do the same stuff, but instead of using the signals from GPS, it's trying to get the signals from the Bluetooth sensors that are installed there. The the problems are still same. So when you're catching the signal, although the signals are stronger because the devices are very close proximity to you, the way the triangulation works uh, is it has the same principle, that it bounces through the walls. It has the physical boundaries, the physical infra impacts the triangulation ultimately, right? So and on top of that, another thing, it can't derive your rotation, which means although I know I am in this room, for, let's say, for navigation and tracking, I also want to know where I am looking into the room. So not just like a blue dot, but when you open Google Maps, you also want to know, yeah, like you see the compass, right? Like, hey, I am facing this way, this way. So that helps like a navigation, like an app to know, hey, are you going this side of the lane, or you're going in the opposite side of the lane? So it also lacks the rotation component.
Okay, let's see if I understand right. So with these beacons or sensors, it's happening the very same thing as with the satellites, that I need at least three sensors to catch me, to like locate me, for the whole system to be able to give me a position, a location. Each sensor or each beacon can just say like, you are within 3.5 meters, for example,
Yeah.
from me. Yeah, but it doesn't really know which direction or where exactly. It only knows that it's 3.5 meters, for example, based on the strength of the
Yeah.
signal. And I need another two for the system to being able to just actually locate me. Am I right here? Do I
That's
understand it
that's
right?
right. Like, so you need at least three signals to, coincide and triangulate your position. Hey, this is how the line of sight matches. According to this signal, this sensor, you are in this line of sight at this distance. According to this sensor, you are in this line of sight, and where they coincide in the physical space, that's how they work. And that is where that's where their position is with respect to those three sensors.
Okay, and And the typical precision or accuracy of these beacons is within like decimeters, right? In tens of centimeters, let's say, or in a meters.
It really depends. So if you are like uh, 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 in a very I mean, if you want a higher accuracy, you can install as many sensors as you want, and it can then, let's say, give you accuracy less than 1 meter, but then it increases your cost of deployment significantly, because the more you the no, the number of sensors you install in the physical space, the higher the accuracy you get, but it still be limited to, let's say, in centimeters, or let's say tens of centimeters. But the cost function is going higher and higher, right? So the amount of investment is not giving you that fruitful investment in terms of accuracy.
With your visual positioning system, uh, we are not speaking about any beacons. You are working without any additional hardware. Am I
Yeah, so
correct?
that's the just coming back to your initial question, right? How, let's say, a multi-set a visual positioning system is, different or better than, let's say, a traditional positioning based system which relies on Bluetooth or Wi-Fi or UWBs. Is the first thing is no infra required, which means, hey, if you already have a 3D scan, you don't need to install anything else in your infra at all, right? Which means you don't need to go on the site, you don't have to procure so many sensors, you don't have to drill so many holes in the physical infra, and then have the wiring, have the all the mechanism built in, right? So the initial investment becomes significantly low because it's completely hardware free. It's simply relies on a database, which is a scan, a digital twin of that particular environment, and tries to match your camera's frame with respect to an existing database, right?